See that tiny thing right there on the screen? That little module right here that I'm playing with my fingers? That's a photo interrupter module, and we're going to go over that today, and I'm going to show you everything from how it works to how to actually use it in a practical environment. If you don't know any code at all, or you don't understand electronics at all, this is exactly the type of video for you. If you do understand that stuff, you'll be able to skip over some of the basic explanations that I'll go through, but this video is really meant for people who just want to get started but don't know how. Hope this video helps you out, and if it does, please do give us a like and maybe subscribe to the channel if you want to see more. So the way this module works is it has this U-shaped item in the front, and what happens is light goes out from one side and light comes in through the other. And it has this circuit of light. And the second the light is being dimmed or being extended or anything like that, it throws that value into the computer. And we can use that to decide if we think something's blocking the U-shape. So if I was to go and take this piece of plastic and shove it right between the two sides of the center like this, we should get a lower value of light because I'm actually blocking it, like physically blocking it in between the U-shape. So it should be recording that and sending that to us, and then we can use that to decide if we want to do something. Typically this type of technology is used in garage doors and things like that, where they have a laser going from one side of the door to the other. And if you cross in front and lower the amount of laser that's touching the sensor, it's going to decide that, oh shit, something might be in front of the garage door. We should stop closing the garage door and retract it all the way out. Here's a little video explaining what that looks like.
When the safety reversing sensors are misaligned, the door will not close from the remote control, and the garage door opener lights will flash. Locate the receiving sensor, which has a green LED. The receiving sensor LED will be off, dim, or flickering, indicating the sensor is out of alignment. When the receiving sensor LED is properly aligned, it will glow steadily.
Now we don't have an exact use case for this video, and I'm not going to go and build a whole machine, let's say like a 3D printer, and tell it, hey, when the 3D printing tool is reaching its end, you should tell it that this is the end. What you're going to need is 3 cables. I like to color code my cables, so 1 power, 1 ground, and 1 signal, an Arduino, and an Arduino power cable. Once you got those, let's put everything together. We got our sensor itself. If you look at your sensors, they always have symbols. So here we have a minus and an S telling us it's ground, power in the middle, and then signal on the end. So we're going to go and grab our black cable and plug it into our ground, and take our red cable and plug it into our power, and then we're going to take our signal wire and plug it into the last signal port. Now all we got to do is wire these 3 to our Arduino. Now, the way Arduinos work is you have power outputs, ground inputs, and then you have a bunch of inputs and output ports all over the board. But you have some that have A next to them and some that just have a line or nothing next to them. The difference between these two is these are analog and these are digital. Analog give you a lot more detail in the response, so it'll tell you a number between 0 and 1,000, comparing to digital, which usually gives you like a 0 or 1. So the first thing we're going to do is plug in into our 5 volt, which is right here. We're going to plug into the ground, which is right next to that. And then we're going to plug this into our A0, since it's the first analog input. Make sure everything's plugged in properly, and always check this to make sure it's plugged in as well. Check that S is the first one, power, and then ground. And now you're good to go. All you got to do is plug in your Arduino to your Arduino power cable, and then send that off into a USB port on your computer. You should see that the Arduino flashes a couple times. That's meaning it's actually connecting to your computer. Your sensor should not have a light on it because it's not being turned on, but when it is turned on, it might have a light on it. This one does not have an LED on it. And now we're good to go on the computer and write some code. When it comes to writing code for Arduinos, I tend to use the Arduino IDE. I know it's white theme, I'm pretty sure I can change it, but it doesn't matter. And this is probably the easiest program you can use when you're first starting off. You can go and use other editors that you usually use for other types of development, but this one works really well. Inside every Arduino program, you have a setup and a loop function. This is how an Arduino works. The first thing it does is set up a bunch of things, and then it loops over and over and over endlessly until you turn it off or tell it otherwise. The first thing we're going to do is declare what port our photo interrupter is being plugged in on, which as we showed earlier, was A0. So we're going to just write that out quickly. I'll just call it PI for photo interrupter, and then we'll put A0 and go on the next line. which is where we're going to put a variable called value. You don't have to do this. You can just print out the value straight out from when we look for it, but I like to do this in case I want to use it somewhere else in my program. It's just a good habit to have. Then in our setup, we have a couple things to do. First thing we have to do is set up our console. So this isn't too complicated. You don't have to focus on this too much, but setting up your serial.begin pretty much tells the computer, hey, when something happens or when I ask you to print something out, this is where you're going to print it. So usually I just go to 9600. And that's it, all we have to do right there. Then our loop, which is the easiest but most important part, we have to grab our value and set it to analog read, and then the port we're using, which in this case is already in a variable, so we just put pi. You could also just put A0 here and not do the original value at the top. After that, we're going to do serial.println, which is just going to print on a line for us. And we're going to tell it to print out the value we just grabbed from the analog read. For a digital module, you would just use digital read. For analog modules, you use analog read. It's just telling it what kind of port it is and how to read it. Then the last thing is we want to add a delay, so we're just going to do delay 50. This is 50 milliseconds long. If you added 1,000, it'd be 1 second long. And we're just going to verify it, compile it, make sure it works. We don't got any errors, so we're good. Then we go on to upload it. And we uploaded it. So it seems uploading, I actually have an issue. It's stuck on loading. So if you go to Tools, Board, you should be choosing the board you have. I have an Arduino Uno. And then for port, you should be choosing the one where your Arduino is plugged in. And it actually tells me that Arduino is plugged in on 6. So I'm just going to click on 6. I'm going to compile it and upload it again. And there we go, it worked. Now, if you go again, Tools, Serial Monitor, you'll open up this window right here where you'll see a bunch of numbers printing out. These are the values every 50 milliseconds from our sensor. Now, if we actually grab our sensor and take a material, which I have 4 different ones. I got plastic, tube types of paper, and metal. Let's start with the thinnest paper. Take that, stick it in the middle, keep an eye on the values. They just went up like crazy. Look at that, 940, 930, all the way up there. Let's grab a different. Now we're at 700. So the first paper seemed to block light easier than the second one. Here we got a nice stick of plastic. Again, wow, the paper was actually less transparent than a piece of plastic. And then the last one is a big piece of metal, which I want to make sure I don't touch on the terminals. And look at that. This one's obviously going to block the most, with literally the highest number we can get to, 1,000 something, 1,020, whatever it is. So this shows you how this sensor works. It's got, again, a U-shaped gate. When something goes in between the gate, like this big metal piece here, we could see that light is being blocked and it's showing us a value in the console. Now, if we wanted to, we can use that to activate an LED. We can use it to open a garage door. We can use it to do whatever we want. Hopefully, you guys got a good explanation here of how to use this sensor and how everything works. If you have any questions, please, please, please do comment below or hit me up in Discord. I'm always up to help people out. I can't spend 10 hours with you, but I can always answer a couple questions that you got, or we got a bunch of cool people in Discord who can help you out as well. If you enjoyed this video, give it a like, maybe subscribe to the channel, and we'll see you in tomorrow's stream.